Hey everybody, thanks for clicking on this video. Today we're going to be practicing the idea of matrix order. This is a very introductory concept when we deal with matrices, because normally when we deal with the ideas of adding and subtracting and multiplying, it's usually with numbers. But matrices brings in the idea of, well, we can do more than just add numbers, we can add matrices. And matrices is just a whole bunch of numbers put together. And so the way we organize them, the way we lay them out, is what we call matrix order. So if you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So here we have some matrices, and we want to determine the order. Now order basically just means the number of rows and the number of columns. That's all. Number of rows, the number of columns. Now the thing to remember is that the rows are these. They go across, whereas columns go down. So this one has 2 rows, so we write a 2 by, and then we have 3 columns, so it's a 2 by 3 matrix, and that's the order, and that's all it is. And so when we're looking for order, find the number of rows and the number of columns. And then finally it asks whether it's a square matrix. So in order for it to be square, these two numbers have to be the same. So this is not square. So for the next one, first look at the number of rows. So 1, 2, and the number of columns, 1, 2. So this is a 2 by 2, so this is a square matrix. For the third one, when we count our rows, we have 1, 2, 3. So this is 3 by, and we have 1, 2. So this is a 3 by 2 matrix. So that's not square. And this is important because here we have a 3 by 2, whereas matrix A up here, that is a 2 by 3. And so these are two very different arrangements. And so this is why order is so important, because it tells us how are we organizing all of these numbers. With letter D, we just have one row. There's no second row underneath it. So this is 1 by, and we have 1, 2, 3. So this is 1 by 3. And that's not square. And then finally, matrix E, this one often gets people because, well, there's just one row and there's just one column. It's just one number. That's right. This is just a 1 by 1 matrix, which is also square. So, on the next page, we have this matrix A, and this is a 3 by 4. 1, 2, 3, 4. And what we want to know is we want to find these following. And so what we've got is we've got these little letter A's with these little numbers next to them. Now, what that means is anytime we refer to a capital letter, we're talking about the matrix as a whole. Anytime you see a lowercase letter, that means a number within the matrix. So the question is, which one is it? That's what these two numbers are. The first number tells us which row we're looking in. So A1 tells us it's going to be in the first row, and the 3 tells us it's going to be in the third column. So that means first row, third column, it's that number. That's the 3. So our second number says we want to find the number in matrix A that's in the second row and in the fourth column. So that's going to be this number right here, -1. For the fourth one, we have A32. So that means we want to find the number in the third row, right here, and in the second column. So that is 4. And then finally, A33, we want to find the number that's in the third row and the third column. So third row and third column, so we have -1. So we use the row and we use the column to identify where numbers are located within the matrix itself. So finally, what we have is we want to find this matrix. And so what we have is we have capital letter C out here, and then we have lowercase c. And then we've got this, we don't have numbers, we have I and J. And then it gives us this. And this is our little definition right here. This tells us how to figure out what the numbers are. And so our first number is I, and it says 1 is less than I is less than 3. Well, normally the first number I is the row. And so this is saying it could be a 1, a 2, or a 3. So that means we have 3 rows. And j, the second number, says it can be between 1 and 4. So that means that we have 4 columns here. So if I put in 12 different blanks right here, we need to fill in these blanks in order to figure out this matrix. So right here, this is the spot for the first row and the first column. So to fill in this number, I would plug in a 1 for I and a 1 in for j. So I get 3. And so now over here, if I move over across the row, I is still 1, but now j is 2. So that means this is 5. If I move, now let's say I move down from this point. Now I'm in the second row and the second column. So now I'm plugging in 2 in for I and 2 in for j. And if I go down again, here I'm plugging in 3 in for I and 2 in for j. And we get 7. So let's finish out this row. Let's see. So if I plug in 1 in for I, and I plug in 3 in for j, I get 7. If I plug in 1 in for I and 4 in for j, I get 9. Now we go 3, 5, 7, 9. Each time we add 2. Now let's see what this number is. If I plug in 2 in for I and 1 in for j, that's 4. So it looks like we go up by 2 each time. So here, if I plug in 2 in for I and 3 in for j, that means we get 8. And if I plug in 2 in for I and 4 in for j, I get 10. So looking at this pattern, as I go across the matrix, I go up 2, but as I go down the matrix, I add 1. So that means this should be 5, 7, 9, and 11. So all of these numbers are just following this rule right here. So now we're doing the same thing for matrix D. But here it says that I is between 1 and 4. So we've got 4 rows. And j is between 1 and 2. So we have 2 columns. So 1, 2, 3, 4. 1, 2, 3, 4. So if I plug in 1 in for I and 1 in for j, I have 2 to the first times 3 to the first. That's 6. If I plug in 1 in for I and 2 in for j, 2 to the first times 3 to the second, that's 18. Now down to the second row. 2 in for I, 1 in for j. 2 squared times 3 is 12. And then 2 in for both I and j, that's 2 squared times 3 squared. So that's going to be, let's see, times, that should be 36. So now, 3 in for I and 1 in for j, that should be 24. And now, 3 in for I and 2 in for j, that should be 72. And then we have 2 to the 4th times 3 should be 48. And that should be 144. And so again, we're just following this rule to populate all the individual numbers for this entire matrix. So this entire capital letter D is represented by all of these numbers like this, just like this capital letter C up here is representing all of these numbers right here. Thanks for watching. If you like the video, give it a thumbs up. For more videos like this, click the subscribe button. If you found this helpful, please share it. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.